Master strategies to graph trigonometric functions step by step, showing all the transformations and the critical five key points. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel. We have thousands of videos for you to explore and master these strategies. In this video, we're discussing how do we sketch transform trigonometric functions. We have taken up sine function. So g of x equals to 3 sine half of x minus pi by 6 plus 1 is what we are going to sketch in this particular video. It comes as a request from one of our subscribers who want to understand each and every step of transformation and also see visually how it appears on a graph. So we'll walk you through all these steps. So basic parent function, as you can see, is sine x, right? So we'll begin with sine x, and then we'll look into the period, which is half. So we'll draw the function sine of half x. So once we do this horizontal stretch by a factor of 2, the transformations are known to you, I hope. Then after that, we can do the vertical stretch, which is 3. Let me change the ink because I'm going to sketch each function in a different ink. So it'd be 3 sine half x. Makes sense, right? So that is a vertical stretch by a factor of 3. And at the end, we are going to do the translations, moving it 1 unit up, and then we will translate it pi by 6 to the right. Okay, so then we'll do 3. We can combine the two steps, but let me do it in different ink. Let's have more options here. Okay, so we can have some dotted graphs, right? So what I will do is we'll do this. I'll write this as 3 sine half x plus 1, correct? And lastly, I will finally sketch the final graph in bold red, which will be what we need really, which is 3 sine of half x minus pi by 6. Shifting pi by 6 to the right, plus 1. Is that clear to you? Okay, great. So let's begin with sine x. I took green color for it. So when we do sine x, in that case, we have to look into 5 key points, correct? As you know, the 5 key points for sine x are, it starts with the origin 0, 0. And then at pi by 2, the value is 1. At pi, the value is 0. At 3 pi by 2, the value is minus 1. And at 2 pi, let me write here, 2 pi is back to 0, right? So that is your sine x function, which we are going to look into. Let me put them closer so that we can actually continue with this later on also. So let's write down sine x here. So the 5 key points, as I said, was 0, 0. And then we have pi by 2, 1, pi 0, 3 pi by 2 minus 1, and 2 pi 0. So on this scale, you can see we have 0 here and then 2 pi, correct? So that is 2 pi for us. So we'll divide this into 4 equal parts, which is right there, half and then half of half. Each half represents a quadrant. Pi by 2, you are moving to the next quadrant now from 1 to 2, right? And see how the value moves. So value goes from 0 to 1 to back to 0. Mean you can say x's, right? That would be a good term to use. And there you go. So you have this graph, which is the sine x graph. Makes sense. So we got sine x. Now I will draw sine of half x. Now, when we do sine of half x, the y values remain same, the x values double up. It is horizontal stretch by a factor of 2. So the values will now be, this will remain as 0, 0. But we'll just multiply all x values by 2, right? So this becomes pi but 1, right? 2 pi, 0. This is 3 pi minus 1, and this is 4 pi, double up, right? For each x value. So instead of ending at 2 pi, now the graph ends at 4 pi, correct? Which is right there. So every value stretches right. So now we have a graph where the last point goes to that, the first remains at 0 itself. So it is horizontally stretched as you can see. So instead of pi by 2, the first peak comes at pi. Then the 0, which was at pi, will be at 2 pi. Minus 1 value will move to 3 pi, and we have a graph here which I am drawing in dotted line. So this is horizontally stretched by a factor of 2. Is that clear to you? And you can also see all the points. Third is vertical stretch by a factor of 3. So let's write it down. So we have 3 sine half x. So this time I'm only going to multiply the y values by 3, right? Leaving the x values as such. 0 remains 0, right? So pi 3, get the idea. 2 pi 0, 3 pi minus 3, 4 pi again 0, right? So, so the pink graph which you are seeing, the dotted one, will start with 0 again because we are multiplying the y value which is 0 with 3. But the first value, which is the peak at 1, now becomes 3. So which is right here, right? So 3 times. It's going out of my scale at present, okay? And I mean into the writing which I've done. Zeros will be back to 0 as you can see, right? However, the peaks are going to the extreme, right? So this value also goes to minus 3. So we have a graph which is kind of like this. You see that? You see that? Right. Let me redo this part. It goes to minus 3 back to 4 pi. So we have incorporated the 3 times thing, right? Now we have to shift the whole graph 1 unit up. So let me just change this. 3. Okay, let me write here 3 sine half x. And we are going to add 1 to it. So everything goes up by 1 unit. So you can actually rewrite the points. So this time the y value starts with 1. So you're just adding 1 to the y values. The x value remains same, right? So 3 becomes 4. Very good. So use this information more to get the points. We'll see the sketch of the graph on the next page. Okay, so bear with me. So here will be 2 pi plus 1. We are just adding 1 to each y value, right? X value being same. Minus 3 becomes minus 2 and 0 becomes 1. So the axis changes, and this time the major change which happens is that the axis moves up, right? So all these zeros will now move to this point, which is at 1. Makes sense? And all other points will move up by 1 unit, right? So the peaks will be further up by a unit. You get the whole idea. And the graph will be this one, right? Okay, great. So it looks nice though, right? Because of different colors, I think you can still appreciate it. So we have done up to the translation vertical, and the last one is the final graph when we are going to sketch our function, which also incorporates the translation pi by 6 to the right. Now, in this particular graph, as you may see, Pi by 6 is this much, right? So this is pi by 6. So we are going to just change each point by pi by 6 to the right. You see that? So pi by 6. And we are going to sketch the final graph using this pi by 6, correct? Since it is very messy, I'm not using the red ink now, but I'm using the highlighter, right? Okay, correct. So this, let me now finish it off with the red. So it starts with pi by 6, as you can see, 1, right? This is at 1, and this is at pi by 6. Is that clear to you? And it goes up to this point, then again pi by 6, it comes down and ends up pi by 6 more than 4 pi, correct? Pi by 6 more than 4 pi, which basically means 4 pi plus pi by 6. 6 times 4 is 24. So this point here is 25 pi by 6. Makes sense. So that becomes your new domain for one cycle, right? You can actually repeat this cycle and get your function. Is that clear to you? So this is when you are asked to show each and every transformation along with the points. Right. Now, I'll also show you the second way, which is more efficient to sketch the graph. Okay. So here I'm using second method. So I'm writing this method too. I hope the first method is clear to all of you, right? We actually did step by step transformation, showing you all the coordinate points and how the graph moves. Now, method two, which is a practical way of doing it. So, practically, what we do it is that we actually start with the translation because that is the axis, right? So, we know that the axis for this is y equals to 1, right? So, we'll just sketch this axis 1 first, right? So, this is my axis at y equals to 1. You see that? Now, we look into the amplitude. Amplitude really means that from the axis, you'll go 3 units up and 3 below, right? So 1, 2, 3. So that becomes your maximum, correct? And 3 down, 1, 2, 3. So this becomes your minimum. You agree with me, right? So we know, I'm just drawing the dotted line just to show you that this is the frame under which we are working. So 1, this was 1, 1 plus 3 is 4, and 1 minus 3 is minus 2. So we got our extremes, we got the range of the function. Okay. Now, let's look into the domain of one cycle, right? You understand? Which I am deciding with the time period, which is given from k value of half, right? So we know t is 2 pi by half in this case, which is equals to 4 pi. So 4 pi is where for me? 4 pi is right there. So this becomes one frame. Do you see this 4 pi? Okay, great. Let me write 4 pi here. Makes sense? So we have one cycle from 0 to 4 pi. What we are going to do now is divide this into 4 parts, right? So half of 4 pi is 2 pi, correct? So see, I'm just dividing it. I'm just showing you all these things in the video so that it's absolutely clear. And half of 2 pi is pi. It was basically a step where the time period of one cycle is divided into 4 equal parts. If it was t, we're looking at t by 2 and then t by 4. 1 t by 4, 2 t by 4, 3 t by 4. So we got 4 parts representing 4 quadrants. Makes sense, right? We are talking about sine function. Sine function starts from axis. So the sine function is what? It is axis, right? Maximum, axis, minimum, and then axis. Makes sense? So axis and next point maximum, that was a mark point, right? And then back to the axis and then to the minimum, makes sense. And then back to the axis. Does make sense to you? So we basically got this particular graph. Let me join it with green color, right? This graph is much neater than the previous one and is much simpler and faster. Start with the axis, mark the maximum minimum, divide the time period into four equal parts, and then axis maximum, axis minimum, axis. You have a sine graph. Is that clear to you? The last thing which you need to do is to incorporate the phase shift, which is minus pi by 6. Means I have to now shift the graph to pi by 6 right. Correct? So, in our scale, we have this as pi by 2 and this is pi by 6. Two divisions are pi by 6 in this particular graph, right? So, I'm marking pi by 6 units from each key point, correct? So those are my key points which are being joined with the final graph. Make sense? See how neat it is and perfect, correct? So advantage with this method is that we did not calculate the key points transformed. You get the whole idea. We have worked with this concept of axis maximum minimum axis. Hmm? We did not do the calculation which was done earlier for finding x and y final points. But you can see it on the graph that the initial point starts with pi by 6, right? And each value has been added by pi by 6. You do your math, right? And 4 pi plus pi by 6 will give you 25 pi by 6. Makes sense, right? So you have your final graph. This is how you should be sketching any trigonometric function, maybe sine or cosine, if conditions of transformation, show transformation, all those things are not given to you. If the question is sketch the graph, get an idea. Okay, so I hope all this is clear. So for the benefit of our viewers, I messed around the key points. What we've done here is revised uh, how do we calculate the key points, which I did. So basically, what we did was that we started with the x, y, five key points of sine function, which are given here. It starts with 0, goes to maximum 1, back to 0, minus 1, and to 0. The x values are 0, pi by 2, pi, 3 pi by 2, and 2 pi. One cycle of 2 pi. Now, in this particular case, as you can see, it is a transformed function. The x value changes as per parameters given within the argument, that square bracket. So you do the reverse, right? Multiply the x with 2, right? Because of half, and then minus pi by 6 is kind of add pi by 6. So you get your transformed x values, and then for the y values, look at outside. Outside we have 3 and plus 1, right? So 3 times y plus 1, correct? So once I have written these x values, so that is the column transformed x values, and then y values, this is the y values. And I've done all the calculation which I had shown you on the very first screen, final values, right? So it starts with 1 plus 3 means 4, and then back to 1, minus 3 means minus 2 means from 1, right? And then back to the x's, which is 1, correct? So you get all this, and once you do all that, you get a very neat graph showing shown here, right? So the graph in this one is your sine graph, right? So this is your sine x, and this is your g of x, which is shown here, right? Of course, the maximum being 4, right? And the minimum being uh, 1 minus 3, which is minus 2. this is your axis at 1, right? So this is y equals to 1. Makes sense, correct? So so that is how the graph is. We have moved right starting from here, pi by 6, and ending there, which is 25 pi by 6. Of course, it is a periodic function, then you're supposed to extend it as shown here in this particular graph. Sometimes two cycles are required, so accordingly, select a scale so that you can represent both these cycles. So I hope you have understood each and every step clearly. As an exercise, you can actually sketch a cosine function similar to this, and then watch my videos to really understand graphing trigonometric functions or any topic for that matter, right? How do we sketch graph of a trigonometric function which is minus 2 cos of half x plus pi by 6 plus 1? I'm going to share with you two different methods of sketching this graph. Method 1 will involve complete transformations, step by step, how the key points change and how the graph changes. And method 2 is the alternate method in which you can sketch the graph very fast without even calculating the key points transformation. Let's look into this strategy of sketching graphs. You can also follow my playlist to practice and get better marks. In case you want to learn, you can send an email on globalmathinstitute@gmail.com. Now, let's talk about sketching the graph of the function f of x, which is minus 2 cos half of x plus pi by 6 plus 1. Method 1, where we are going to discuss the transformations. So basically, we'll begin with the cosine function. Let me write cos x and then incorporate the transformation, which will be cos of half x, that is horizontal stretch by a factor of 2, and then we'll do the vertical stretch factor with reflection, so then be minus 2 cos of half x. And after this, we are going to add up the translations. One translation is towards the left, which is by pi by 6, and the other one is moving up by 1, right? So I'll put them together. So what we have here is minus 2 cos of, let me write everything together. That is the final function, okay? So pi by 6 left and plus 1, correct? So with that, we'll be able to sketch the whole graph. So five key points which we will be considering, which are standard, are cosine function, as you know, starts with 0, 1, right? And then it goes to 0 for pi by 2. So let me write down the 5 points first. So it'll be at pi by 2, the value will be 0. At pi, it will be minus 1. At 3 pi by 2 is going to be back to 0. And at 2 pi, we'll get again the maximum value of 1. Now, when I say cos of half x, in that case, the x coordinate value stretches by a factor of 2. So the point here will not move vertically. Vertical point will remain same. Horizontal will be multiplied by 2. So we have 0, 1 here. Multiplying pi by 2 gives us pi, y value remaining same. This will give me 2 pi minus 1, and then this is 3 pi 0, and that is going to be 4 pi 1, right? So what you have seen here is that the xy point here will be now as 2x y, correct? Now as soon as you do minus 2 times half x, the a value now gets multiplied by minus 2, right? So let's use a different ink. So we are comparing with the cos half x. The x values will now be same. The y values are changing. Multiply them by minus 2. So it be 0 minus 2. Here the x value remains same. Y value, because it is 0, 0 times anything is 0. Now the third one, at 2 pi, the value will be minus 1 times minus 2, which will be plus 2. And at 3 pi, again 0. At 4 pi, we expect 1 to become minus 2. So the graph is actually reflected. And as you can see, at this stage, the y values are minus 2 times the initial y value. Correct? See how the points are changing. Now, at the end, we are looking into two transformations. One is the translation towards the left. So let me rewrite this as 2x minus pi by 6. That represents the horizontal translation, pi by 6 left. And then, as far as the y value is concerned, minus 2y we had, to that we are going to add 1, correct? So, adding minus pi by 6 to 0 will give us minus pi by 6, and adding 1 to minus 2 will give us minus 1. Correct? Now, minus pi by 6 will be 6 pi minus pi, which is 5 pi by 6. Correct? 0 plus 1 is going to be 1. 2 pi minus pi by 6 means 12 minus 1, which is 11 pi by 6, right? And 2 plus 1 is 3. The next value, which is 3 pi 0, will now be 3 pi minus pi by 6. 6 times 3 is 18, minus 1 will be 17, right? 17 pi by 6, 0 plus 1 is 1. The last value, which is 4 pi, when you minus pi by 6, then it is 6 times 4 is 24, minus 1, 23 pi by 6, and the y value minus 2 plus 1 will be minus 1. So finally, what we see is the graph of one cycle will be from minus pi by 6 minus 1, right? So it's going to start from the bottom and it will go like this. You get the whole idea, right? So that is one cycle where the initial point is minus pi by 6 minus 1, and the final point is 23 pi by 6. I should have written, right? So not 3, by 6 minus 1. So this is 23 pi by 6 minus 1, and that is minus pi by 6 minus 1, correct? The maximum value will be 11 pi by 6 pi by 6, 3. So that is going to be your graph. I hope you have understood the whole strategy, correct? So once you have the points, you can easily sketch the graph. Perfect. Now let me show how these points will look like on the graph. So let's begin with the cos x function. So let's say, we'll begin with cos x. So on this scale, that is 0, 1, and we have a cycle which is here we have 2 pi, right? So within 0 to 2 pi, we have one full circle, which will give us the cosine function starting with maximum, then going to 0, coming back to minimum, going to 0, and to maximum. So this is the starting point of one cycle of cosine x. Agreed, right? Of course, it continues. So we'll focus on only one cycle. Makes sense, right? Perfect. Now, I want to incorporate half of that horizontal stretch by a factor of 2, right, which is half x. So that means it is going to get stretched. So this 2 pi will become 4 pi, right? So 1, 2, 3, 4. So that is a 4 pi. So now the function is going to end here, one cycle of cosine. It will start again from the same point. However, each point is stretched by a factor of 2. So this was at pi by 2, it will come to that point. This is at pi, it will go to 2 pi. This 0 will now go to that point. And so we have a curve which is kind of like this. Makes sense, right? So this is at 4 pi. We are sketching the graph of cos half x. You understand, right? Perfect. Now, we can do minus 2. So let me write down minus 2 cos of half x. Make sense? So minus 2 means multiply everything by minus 2 vertically. It is getting reflected, and this point comes here, right? So that is our minus 2. Makes sense? But 0 will remain at 0. The one value becomes 2, right? 0 remains at 0, and there you go, right? So what we have is, let me draw like this. That smooth curve is kind of important to sketch, right? Yeah, it cannot be a corner. Since it is a periodic wave, it is a good practice to sketch arrows at the end. Now, I know I took both translations, vertical and horizontal, together. In this case, I'll prefer to put them separate. So let me just first sketch the vertical translation of 1 unit up, which is, will now sketch minus 2 cos of half x plus 1. Get the idea. Plus 1 means the axis itself will move 1 unit up, right? So instead of the y equals to 0 being symmetric, the line of symmetry now, also for the axis, will be at 1. Every point will move up by 1 unit. You get the whole idea, right? So we are moving every point up by 1 unit. And then what we observe is that the cosine function will be kind of like this, right? Showing you in blue, right? Perfect. Now, finally, we'll sketch our final graph, which is the function itself, this particular function. It really means we are moving each point pi by 6 to the left. So this is what we need to incorporate. So pi by 6 is 2 division for me. So every point I'm going to, I'm here, so I'll move it here, right? So pi by 6 to the left. So see, that is how I'm going to move the point and then sketch the graph. So that is my points, correct? So this each division is pi by 6 to the left. You understand, right? So, which is 2 divisions on this particular scale. And what we get here is this graph. You get the idea, right? So that is the final graph, which is the graph of our function, which we're talking about. So in this particular slide, what you see is complete transformation as you see step by step on a graph. Perfect. So with that, we complete this transformation. Now, let me see. That was our method one. Let me discuss with you method two, right? So in method two, once again, we are going to sketch the same function, which is for us minus 2 cos of half x plus pi by 6 plus 1. Now, see the beauty. This time, we are going to sketch it without calculating any point whatsoever. Okay. So, how are we going to start? We are going to start with the axis of symmetry. So, we'll start with the axis. Axis is at y equals to 1, which is this particular point, correct? So, at y equals to 1, I'm going to draw the axis. There you go, right? That's the first thing which I'm going to do. Now the amplitude, which is 2 unit, right? So we have amplitude. So amplitude is 2 units. That means from here we go maximum 2 units and we go down 2 units. So this is the framework under which we are going to work. Is that clear to you? So the maximum will be 3 and from 1 to down will be minus 1. Makes sense, right? And then we are going to look into the time period t, which is 2 pi by k, and k is half for us, right? Which is 4 pi. So one cycle will be 4 pi long. So 1, 2, 3, 4, which is 2 pi, 1, 2, 3, 4, which is 4 pi for us. So this is the framework in which full one cycle should be drawn. Now, this framework is divided into 4 equal parts. Right? Let me just divide 4 equal parts. So, These four equal parts shows you the quadrants. And as you know, the cosine function starts with the maximum, comes to the axis, goes to the minimum, goes to the axis, and the maximum. So, this is the graph of a cosine function in which everything is included except for horizontal translation. Do you see that? So, let me call this as g of x equals to minus 2. I mean, I should not say minus 2. It is 2, right? But we could have drawn minus 2 also, right? So let me just change it and make it minus 2, okay? Since there is a reflection also, let me reflection about x's. Since there is a reflection, I will now reflect each point to the other axis. So we get these points, you see, after reflection. So now I am sketching the graph after reflection. You get the idea, right? So I have incorporated the reflection in this particular graph. So once I have done the reflection, I have taken care of minus 2 also. Now the last step is phase shift of pi by 6 to the left. So in a way, as you can see here, with this framework, we have not taken any key points using calculation, but common sense, right? One cycle of 4 pi, which is the time period, divided into 4 equal parts of pi each. Since it is reflected, we have started with the minimum, gone to the axis, maximum. So, as you can see here, it goes from minimum to axis to maximum to axis to again minimum, correct? This is because of the reflection part, right? Now, the last thing is to shift it pi by 6 to the left. So, two divisions are marked as pi by 6 in this particular scale. So we'll shift this and sketch the final graph joining these points. Makes sense, right? So we have this graph here, and then you can continue. Perfect. But I hope you have understood. How do we sketch the graph without calculation? So that is our method number 2. Especially when you are doing at higher level, this is what you should be doing, right? Okay, great. To summarize what we did the calculation of the points which are being calculated right there. So you will notice that xy points were mapped to the x values were multiplied by 2, right? And then subtracted pi by 6. The y values were multiplied by minus 2 and then we added 1. So as you can see, these are the x transform points and these are the y transform points. The calculation being done with starting with maximum going to axis, minimum, axis, maximum. And once you do that, you got these particular points which are from minus 1 to 3, right? And the x values, since we moved pi by 6 to the left, one cycle is from minus pi by 6 to 23 pi by 6, not 24 pi by 6. We have to subtract pi by 6 from it. Makes sense, right? So that becomes the calculation, and this is your final graph, right? So as you can see, minus pi by 6, the graph starts, and it ends 23 pi by 6, right? So this is minus pi by 6 for us, and this end here is minus 20, sorry, plus 23 pi by 6. Makes sense. The maximum being because we added 2 to 1, right? So it goes to this is 1, right? So this is 3, and here it is minus 1. Makes sense? Y equals to 1. So that becomes the graph. The orange line is for cos x, and this is our function f of x shown in red color. So finally, that is the graph which you are going to get. So I hope all these steps are absolutely clear. Well, in case you want to learn in a very short period of time, you can always contact me on the email globalmathinstitute@gmail.com. Our students are right there on the top getting scholarships for the best universities. See, all these steps involved in graphing trigonometric function reciprocal transform trigonometric function which is given to us as f of x equals to minus 4 over 3 cosecant half x plus 2 pi by 3 plus 7 over 3. It involves a lot of fractions and many things to do before we start graphing of this cosecant function. Now, in my playlist, you'll find my method, which is two-step method, which I really promote and I love. You can also follow that method. So, in this solution, which we are going to discuss, first I'm going to discuss at length the two-step method where you can graph this trigonometric function without any calculation of transform points. Important, right? And you can do it in just few minutes. That is the greatest part of it. But however, many times it is specified in the test paper that you need to write down the points. And for that, I'll take in the second half of this video, how do we write down the points? Perfect. So it makes sense, right? So now let's first begin with our two-step method solution. So first we'll consider the basic concepts. And once we have the concepts in hand, we'll sketch the graph. I'll discuss with you some couple of strategies which can help you. Correct. So first step is that we are looking into cosecant. So whenever you have cosecant, that means in your mind, sine function should be there, right? So you know what is cosecant, right? So cosecant theta is equals to 1 over sine theta. So basically, we need to sketch the sine graph. And once we sketch the sine graph, then we from there we can draw the vertical asymptotes, right? Flip and get the cosecant graph. Perfect. So that is the strategy. Now, even before going there, we need to rewrite our function, which in this case should be minus 4 over 3 cosecant. Now, I use square brackets to factor out half, right? So it is half of what comes in the bracket? X plus. Since you factor out half, it should be 4 pi by 3, correct? And here we have plus 7 over 3, correct? So once you have this, you have a couple of things in your uh, mind, and that is one of the most important thing is we have to now sketch, let's say g of x, which will basically be sine function, right? Will be sine of half x plus 4 pi by 3, right? Plus 7 over 3. So that is what you have to sketch. Once you sketch sine function, then it is easy to sketch cosecant function, right? So that's what we are going to do. Great. So remember one thing, when you have this, what is the period? So time period t will be equals to 2 pi divided by half, right? So that means the time period is 4 pi for this particular case. And what is the amplitude? So amplitude basically is equal to 4 over 3. It's always the positive value. And here axis is how much? Axis for the sine graph is y equals to 7 over 3, right? And we have a phase shift. So this is the phase shift value. We'll write p here, lowercase p, as minus 4 pi by 3. So that means it moves left by 4 pi by 3. Now, as you can see, in this particular case, most of the values involved, 4 by 3 is like 1/3, 4 pi by 3 means 1/3. So that helps you to decide on what kind of scale should you be using, right? So let me just use a scale here. I'm not drawing the graph, but I'm just showing you the scale. The minimum deviation which you should have should be 1/3, right? And over here, it should be at least pi by 3, if not pi by 6. So it could be pi by 6 also. So pi by 3 I've written here. So 4 pi by 3 means 4 of these, 1, 2, 3, 4, will give you one full cycle without a phase shift, right? And because the 4 pi phase shift is 4 pi by 3. So that much it will move to the left. So you need a big area to work with, right? So I hope you're getting the point. So once you have pi by 3 as your unit square defined, you can shift left and right by 4 pi by 3. Correct? Making sense. Now, also note that there is a reflection on the axis. So the sine graph basically will be kind of going downwards, right? So let me give you a rough sketch of the sine graph. How should it look like? So we'll have an axis which is y equals to 7 by 3. It has been translated so many units down, right? And period for the sine graph will be 4 pi. However, it has to start from minus 4 pi by 3, right? So this point from where it starts is minus 4 pi by 3. You get the whole idea, right? Minus 4 pi by 3. And it is going to end after one full cycle at this point, and that should be equal to how much? You have to add 4 pi to this, correct? So minus 4 pi by 3 plus 4 pi. So 4 times 3 is 12, right? And 12 minus 4 will give us 8 pi by 3, right? Let me rewrite it. 4 pi plus 12 pi, right? Over 3, which gives you 8 pi by 3. So this point here is 8 pi by 3, correct? What is the maximum and what is the minimum values? Well, for the maximum value, you have to add 4 by 3 to 7 by 3, right? So this will be 7 by 3, right? Plus 4 by 3, correct? Which is 11 by 3, correct? So that is the maximum, and minimum will be 7 by 3 minus 4 by 3, which is 3 by 3 or equal to 1. You get the whole idea, correct? So, so you get the maximum and the minimum points and your graph as shown here. So that becomes a sine function, right? To sketch the cosecant function, what should you be doing? Well, you will actually draw the asymptotes at these points. Wherever the sine graph is intersecting the axis, right? And then flip it over means your graph will be kind of like this. You see that? So that highlighted graph is what represents cosecant graph. So that is the base of our sketching the graph for cosecant function. I hope you have understood these steps. Perfect. So once again, let us now sketch it on the graph paper, right? So here we have a graph paper. As you can see, what we did was we wrote this function as minus 4 by 3 cosecant. We factor out half, correct? We have x plus 4 pi by 3 and plus 7 by 3, right? So first step is 7 thirds. So every division is 1/3, right? So this is like 1, right? This is 2, correct? This is 3, right? So this is 1, 2, 3, correct? You understand? And each division is divided into thirds. So where is going to be our axis? Our axis will be at 7 thirds, right? So 1, 2, 3, 4, 5, 6, and 1, 7. So that becomes the axis. So this is y equals to 7 over 3 on the graph paper, right? Easy? Correct. Amplitude is 4 by 3, 4 thirds, right? So what I will do here is draw a dotted line for 4 thirds, right? So 1, 2, 3, 4, right? So that is the 4 thirds, correct? So maximum is this, right? Which is y equals to 7 by 3 plus 4 by 3. I'm not writing 11 by, or let me write 11 by 3. Is that clear? Similarly, the minimum will be 4 thirds below this, right? 1, 2, 3, 4 at 1. You see how easy it is? We are not really calculating the values. Okay, so this is y equals to 7 by 3 minus 4 by 3, which is equal to 1. Is that clear to you? So we know maximum minimum. Now let's point out the period. Period for us is because cos cosecant half means sine half means period of not 2 pi but 4 pi. So 4 pi and every division here is pi by 3, right? So 1 pi, 2 pi, 3 pi, 4 pi, correct? So that becomes 4 pi, right? So let me just mark it on the axis, these 4 divisions, right? Correct. Now we are also looking for negative, right? Means the sine graph will start from the axis, but it will go downwards. So sine graph will be kind of like this, going downwards, right? So it goes from the axis, so axis to the minimum, sorry, here, then back to the axis, and then to the maximum, and then back to the axis. We are only sketching one wave, okay? So this graph, which I am drawing here, is basically sine function without the phase shift. Is that clear? So what I have drawn here is minus 4 by 3. So let me write down here what I have drawn in blue is, so let me call this as h of x equals to minus 4 by 3 sine of half x plus 7 by 3. Makes sense, right? We have not done the phase shift. Now we are going to do the phase shift of 4 pi by 3, right? So to this, we'll do the phase shift of 4 pi by 3 means moving each critical point 4 pi by 3 left. So 4 divisions, correct? So it is like 1, 2, 3, 4, correct? So that is the position minus 4 pi by 3. So each will come to this point, right? And here 1, 2, 3, 4, correct? This 1, 2, 3, 4. Make sense? From here 1, 2, 3, 4. Correct? From here 1, 2, 3, 4. I'm only drawing one wave, right? So that becomes our final graph, which will be for sine, correct? So that is the function which is, let's call this as g of x, which is minus 4 by 3 sine half x, and within bracket, or let me write x within brackets, shifted 4 pi by 3 to the left plus 7 by 3. Do you see the sine function now? Correct? Of course, this is periodic, so it will move. Right. The idea is to sketch the cosecant function. So cosecant function will have a vertical asymptotes right there. So I am not drawing the vertical asymptotes. Wherever the sine graph is cutting across the axis. Perfect. So for only one wave I am drawing, you can extend this since the function is periodic, right? And now we can extend this and draw the cosecant graph as this. You get the idea, right? Perfect. So, so that is how cosecant graph will be sketched. Does make sense to you? Perfect. So we got a result. So what I've done here is shown you exactly without even doing the calculations how do we draw it. You can of course do the transformations, get all the points and also sketch it. However, this is a beautiful technique. We got all the points on the graph, right? Minus 4 pi by 3 and then from 4 pi take away 4 pi by 3, right? And so we have that point here as 8 pi by 3, right? So from minus 4 pi by 3 to 8 pi by 3 gives you one period of the sine and also cosecant, right? So for your reference, here is the actual graph which it should look like. So once again, let me just tell you that the graph in orange shown here is the graph of sine function, which is minus 4 by 3 sine of half x plus 7 by 3. So this is without phase shift. Perfect. So without phase shift, this orange line is easy because we inverted it, correct? And took our 5 critical points and sketched the graph. Then the second graph which we have drawn is basically this one right here. And this graph is with the phase shift, right? So this is minus 4 by 3 sine of half x plus 4 pi by 3 plus 7 by 3. Makes sense? So we got the blue graph which is shifting towards the left. You see that? By 4 pi by 3. So this point here is minus 4 pi by 3, correct? So we get our sine function. Now to get the cosecant function, we first drew wherever you have this, your vertical asymptotes, correct? You see that? So wherever the blue graph cuts the axis, we have the vertical asymptotes. Neat. And then we flipped with a common point the sine graph to get the cosecant. So that was the way which we had drawn, and it can be extended, perfect, as shown here. Does it make sense to you? The whole graph has been drawn accurately without even calculating the transform points. However, you can always use the transformation to get the points, right? We are back with you. Two-step method, simple and useful. Now let us see how do we sketch this function using the points, right? So we already have a graph. These points help us to verify that the graph is absolutely correct, right? Okay, great. So once again, for the function, we'll factor out the argument. So we can write this function f of x as equals to minus 4 over 3 cosecant, factor out half, and I use square brackets for that. So we get x plus 4 pi by 3, which clearly indicates that the phase shift is 4 pi by 3 towards left. Correct. So we did all the calculations earlier, understanding the transformations. Now, you know, to do this, we should be working on the sine function as we did earlier. So it is sine function which we are going to sketch. Perfect. Now in sine function, as you know, basically sine function looks like what? Sine function starts with the axis, right? Goes up to 1, comes down to minus 1, and then back to 0. Great. So the 5 critical points which you have to always consider are these 5, correct? So we call them xy. So let's call this xy points. Now, after transformation, what happens to these? This is what we're looking for, correct? So the five key points for us are 0, 0, right? And then this is at pi by 2, 1, and this is at pi, right? Let me write this 0, pi, 2 pi, correct. So we have pi again 0, and then we have 3 pi by 2 minus 1 and 2 pi back to 0. Correct. So you got these points. Now, after getting these points, we need to understand the transformation. The horizontal value gets modified because of these two parameters. So let me include them. So it becomes 2 times the x value minus 4 pi by 3, correct? That is phase shift left. And as far as the y values are concerned, we need to multiply by minus, right? So we get minus 4 over 3, right? The y value and add 1 over 3. Correct. So that is how you're going to do it. Perfect. So you can do your calculations and get the corresponding values. Is that clear to you, right? For example, when you put 0 here, it becomes minus 4 pi by 3. And 0 here, it becomes 1 over 3. Correct. Right. So basically, the axis moves to 1 over 3, right? So that means you have to have a scale where each unit is 1/3, right? And then you sketch it. So for you, we have done the calculations. Here is the table of values. So as you can see, the five critical points has been taken for sine x, which are 0, 0, pi by 2, 1, pi 0, 3 pi by 2, minus 1, 2 pi 0. Correct. After applying this transformation to the function, these are the calculated values. So the graph actually begins with minus 4 pi by 3, which is to the left, and at that time the value is 7 over 3. Right, so 7 over 3 is the axis now for the graph. The next value is minus pi by 3 with 1, 2 pi by 3, 7 over 3, and then we have 5 pi by 3, 11 over 3, and this is again back to the axis. So once you have these points, the graph we already drawn and shown you earlier is right there. So you get your blue graph, which is right there, right? So these are the points which we just worked out, correct? So that gives you one sine wave. You can always repeat it. And then once you have the sine wave, then the cosecant is reciprocal. So for the cosecant function, at these points, you have to draw the vertical asymptotes where it is crossing the axis. Once you extend the graph, you get the other points also, right? So I've shown you one wave only, but you can always extend it at least to two, right? So once you have this, then as you can see, flip it to get the cosecant function, which is this, right? So that is how we could actually get the same result which we got last time with my two-step method. However, in this method, we have to do all the calculations which I have shown you, and in two-step method, you don't have to do those calculations. That is one big advantage. However, both methods are followed. Select the one which you like most and explore our playlist to learn. Thanks for your valuable time and all the best.